Hi, this video should show you how to use the new graphical calculator to find area with integration. Okay, so we need to find a nice straightforward area between 3 and 4 and the curve y is x squared minus 4. So on the calculator, you go to graph mode, okay, and then type in your equation. Okay, and draw the graph. Okay, I'm going to adjust those axes so that it's easier to see the curve. Okay, right, so we want to integrate from 3 to 4, so you choose G-solve, which is F5, and then you can't see integration, so you press F6, and there's the integral sign under above F3, so press F3, and to get a straightforward integration, you just use F1, and then you type in where you want to start, so you type in 3, so the lower bound is going to be 3, press execute, and then upper bound is going to be 4, so press 4, and then execute. Okay, and it's found that area for you. So 8 1/3. Right, let's try another question. So then this time, it's going to be a little bit trickier because we're going to have a negative area. So let's just look at that. So we use G-solve, F6, integrate. If we press the integral button and go 0, and the upper bound needs to be 2, okay, then we see that the integral, which is written at the bottom there, is minus 5.3 recurring, so minus 5 1/3. If instead you do G-solve and then F6 and then integrate and choose mixed, okay, and you type in your 0, 0 and your 2, then it gives you two things. It gives you the integral, minus 5 1/3, and the area, positive 5 1/3. Okay, so we'll see how that is particularly useful in the next example. So here we've got a bit of the graph lying below the x-axis and a bit of the graph lying above the x-axis. So we'd expect to normally integrate each of those parts separately. We get a negative part and a positive part. We ignore the negative sign, turn it positive, and add it on. So on your calculator, it does it all in one go. All right. So let's go with integrating. So G-solve, F6, integrate, and this time choose mixed again, and choose to start at 0 and to end at 4. Okay, so that gives you two things. That gives you the integral is 5 1/3. So if we did negative add positive, we'd get a small positive number, 5 1/3, but the total area is 16. So it's done the turn the negative into a positive and add it onto the positive for you. Okay, right, let's have a look at a different sort of question. So this time we have to find the area enclosed by the curve y is x squared minus 4 and the x-axis. Okay, so obviously we want to see what it looks like. So I'm going to just exit and redraw. Oh, it hasn't cleared it. There we go, just clear the screen. So if we want to find the area between the curve and the x-axis, then we want the roots. Now you can separately find the roots, or we can use G-solve, F6, integrate, and there where it says root, and yes, we want this root, we press execute, and then we press the right arrow to go to the next root and press execute. And there we go, we found the area between the curve and the x-axis. Okay, so it does it between any roots you want. And again, the integral is negative because the curve lies below the x-axis, but the area, we just ignore the negative sign and say it's a positive area. Okay, let's try another question. So this time we have a cubic. So we want to find the area enclosed by the curve and the positive x-axis. Okay, so I'm going to exit because I'm going to just deselect that one. Okay, and I'm going to type in my new equation. So we've got x cubed, okay, minus x squared, and then take away 2x. Execute. Right, let's see what it looks like. Okay, I think I'll change the view window just so it's easier to see the areas. So I'll use the initial axes. Right, there we go. So we want to get the area between the curve and the positive x-axis. So that's this right-hand bump down there. Okay, we can use the same process. G-solve, and then integrate, and then root. Okay, I don't want to start at that left-hand root, so I'm going to press the right arrow. Okay, and execute, and then I'm going to press the right arrow again and execute, and that gives me the region that I want. Okay, right, another sort of question. The area between two curves. So we have a line and a curve, and we want to find the shaded area. So we normally need to find the points of integration, points of intersection, and integrate the area under the line, or find area of a trapezium and take away the area under the curve. But on your calculator, again, you can do it in a oneer. So let's just exit. I'm going to delete that one. Okay, so let's go and edit this one here just to make it x squared. Okay, and we'll do x plus 2. Okay, right, so when I draw these, it'll draw the x squared one first. Okay, and I'm just going to move that up so we can see the top of it. Brilliant. So I would really want to do the x plus 2 take away the x squared area. So we do G-solve, F6, integrate, and this time intersect. Okay, for intersect. Right, I want to start with the x plus 2 one. So I think it'll just do the order that they're given in. So it's going to do x squared, take away the x plus 2. But that doesn't matter. Just give us the negative of the area. Okay, so we've got a point of intersection. We want that one. We choose press execute, then the right arrow, and then execute, because that's the next intersection point we want. There we go. And so we've got an area of 4.5. The integral is negative because what it's done is it's done y is x squared, take away y is x plus 2. Okay, there's a mistake on the question on the whiteboard bit here. It should just have x squared. Okay, let's try another similar one. So this is area between two curves again. So we'll exit this and we'll delete these, and we'll put this in the right order this time. Okay, so if I do the upper curve, which is the purple one, so I want to do 11 minus 9 over x squared. Okay, and then the lower curve is x squared plus 1. And we draw both of those. Okay, so there's a lot going on there. So let's just change the view window. Let's go standard at the moment, but I'm going to start at, I only need the positive axis. So I'm going to try typing in 0 up to 10. There we go. Right, that's a bit better. You can see what's going on. So we want the area shaded between those 2 points. So let's do G-solve and F6 and integrate and then intersect. There we go. And we've got our first intersection point, so press execute, and then we go to the right and press execute again for the second intersection point, and there we go. So this time the integral and the area both agree because we've done the blue line take away the red line. So that makes sense.